I just started the recording, and so whatever we have discussed, I think you just remember that. So we deployed everything as a pod, and now let me tell you, vector get pods. If I'll check the number of pods, we have a lot of pod running here. I need to remove everything as of now. So why tab is not working? I just told you delete. No, tab is not working. So what we can do is, so in the current slash root dot bash rc, I can just write this environment for Kubernetes, kubectl completion bash. If you want to, enable tab completion in kubectl command, see, now I get it. Anyway, so that was the variable, and that we are already been discussed in the last session. So what I'm doing is I'm deleting everything whatever we have deployed, so that we can start it from fresh. So all the pods, everything whatever we have created last time, it's now time for deleting. So what we have done is, wonderful. So I hope Anua, you were there at that time, and we discussed about a lot of things like pod and services. So I'm just waiting for deletion of this. Okay, everything got deleted. Now I don't have anything as of now. Fine. So kubectl get pods, we don't have anything. It is in the terminating state. Okay. So in short, if any developer or administrator, they want to deploy their application in the Kubernetes as of now, so what they have to do, they have to take a Docker image and they have to deploy to Kubernetes cluster by connecting one of the major component in Kubernetes master, that was Kube API server, right? So that means Kube API server is that component that you can connect to deploy. But how we are making a unit of it? So we are making a pod, and that pod has the container, and pod has IP address. So everything we are deploying and the Kubernetes master, we have this thing, this the most smallest unit of your Kubernetes entity, that is pod. Now we are deploying pod here, here, and here. Okay, and pod is the only way we can deploy applications here. But today we are going to talk about application downtime, right? So application downtime means in what condition your application can be down. So as a Kubernetes engineer, you have to take the responsibility to make that application up. So for example, if you are a developer or engineer and you have connected to Kubernetes master and requested master to please deploy a pod for you, right? So Kubernetes API server get the request, and the request forwarded to Kube scheduler, and scheduler find the right worker node on behalf of couple of factors. Let's say your pod got deployed here, and when the pod got deployed here, the application is running. To access that application, what you did is you just deployed another API resource of Kubernetes. We call it service. I hope you remember that to access application from outside, we have just deployed service of node port type. So now people can connect to this service by using Kubernetes master or worker, and the service will redirect the traffic to the pod. Okay, everything is working fine. So I think Anua, Rajat, or Nived, if you guys are very much okay with the things that I'm just explaining, although we have discussed it already, just say yes message in the chat window. So now I can just take it ahead. Okay, for Rajat, Nived, it's all good. Anu, if you're also here.
Yeah, hi Ashutosh. Could you
Okay,
hear
hi.
me?
Yes, I can.
Yeah, I'm good, thank you.
Okay, great. So now when we are going to talk about application downtime, so what is the major reason, or what are the major reasons actually that application can be down? The one and only reason is if the pod is not running. Okay, so the basic reason behind application downtime is if the pod is not running. Now, how many reasons can be there if the pod is not running? The first, application is got corrupted. Okay, if the application itself got corrupted, your pod will be automatically shut down. So you just cannot do anything if the application got corrupted. Application is the code itself. Okay, so this can be the one reason. Solution to this problem will be talked about in near future. But the second problem is if your pod is unavailable, right? I can say out of resources. When your application is hungry for the resources, but your pod is not able to assign that, that is the second reason. And the third one, if the worker node goes down, worker node goes down. Which worker node? Specifically, the worker node where your application is running. So in these all cases, 1, 2, 3, I'm going to take the third one as of now, right? There are a list of reasons. I cannot say these are the only ones, but yes, this is one of the major reasons where the application can be down. So I'm talking about the worker node. If worker node goes down due to any reason, so the pod will be down automatically. If the pod is down, Kubernetes is not capable enough to recreate a new pod on behalf of it as of now, right? So that means you have to understand here Kubernetes is not capable enough to recreate the pod on behalf of applications, right? That's why when you talk about application availability or downtime, you need someone who can maintain pod for you, right? That means if the pod is down, they can connect to kube scheduler and API server and request for the same, that people can create another pod. I mean, Kubernetes can create another pod. So deploying application directly in a pod by administrator is never recommended. Okay, because pod cannot take care of itself. So the big line that you can learn is pod cannot take care of itself, right? When I say itself, that means Kubernetes also cannot, right? So rather than deploying application in the pod, that is not a bad idea, but for management purpose, for application downtime, we need to introduce another Kubernetes API resources due to so many reasons, right? And that is replication controller. Although replication controller is also one of the controller in Kubernetes node, but the next generation application management API resources by Kubernetes is replication controller. Okay, what exactly the replication controller can do? Replication controller is something if an administrator is going to connect to the master node on the API server. Okay, now this kube scheduler will find the right worker node, and when you are actually deploying an application, so replication controller has a term called control number of replica, let's say 2. So that means if you are requesting for 2 pods or maybe 1 pod only, let's say 1 pod. So what replication controller can do, it can connect to kube scheduler by API server. Then let's say your pod got deployed here. Okay. Once the pod got deployed here, now the pod is running. If due to any reason this pod is deleting or rescheduling or getting down or it got terminated, so the job of replication controller is to maintain the count. So if you have requested for a single pod, it will recreate the pod again. That means all the time till the time Kubernetes cluster is running, your pod count will be maintained by replication controller itself. So that simply means you don't have to worry about any of the worker node goes down. Even there is a need of rescheduling of pod from worker node 1 to worker node 2. Still, the replication controller will make sure that every time or all the time you have number of pod maintained over there. Okay. And replication controller is also responsible for scaling the pod. So we can scale from pod 1 to n number. That means if you need, then definitely you can increase the number of pod for same application. So you can have pod 1, 2, 3, 4, and these pod can be distributed across multiple worker nodes. Okay. So to maintain the scalability, maintain the count, at least you can have a replication controller. Behind the scene, the reality is replication controller is creating pod, right? We are not directly creating. So this will be taking care of anything, right? So your application is still running in the pod itself, but the pod is maintained by replication controller. So I hope the concept of replication controller is to maintain the pod count in Kubernetes API resources. Okay. So if you all are understanding it very well, just say yes, so that we can, just take an example of how we're gonna create replication controller. Okay, wonderful. So by default, we don't have any, dry run kind of thing in replication controller. That means, let's say, if I'm going to create, okay, a Red Hat online, and here I'm going, right? And in this location, if I'm showing you the how we are creating pod in generally. So we're creating pod 1, just a demo, right? Nginx and hyphen port 80 hyphen dry run hyphen o yml. Okay, these days you don't have to supply a restart policy for creating a pod, right? Although in the last session I have told you restart policy is required to create pod, otherwise it will not be created. But these days, when the Kubernetes most recent version came in picture, without even restart policy, you can create the pod. Okay. Once you have created the pod, so you don't have to worry about anything. Everything will
So,
be.
one quick question.
Yes.
We are using which version of Kubernetes right
The
now?
most latest Kubernetes 1.
1.18?
Yes, 1.
1.18, right?
Yeah.
So this one, when you do a kubectl run command, it does not create the deployment configurations or anything, right? That's a
No,
separate command.
it does not. It does not.
Yeah, so this one just creates the pod.
Yes,
Yeah,
because
that's good. That's good.
yeah, go ahead.
So then we'll have to create a kubectl create deployment config, and for that, then we can do the replacement configuration and everything, right? But this command won't do it.
Yes, yes, yes.
So then
Even
why
this
a restart policy?
actually this command was creating deployment in the earlier time,
Earlier versions,
lower
correct?
version, and that time you have to put the restart policy never here if you want to create
Yeah,
pod. But
that's right.
as of now, this has been removed by Kubernetes. Even if you don't supply restart policy never, it will create pod. But in the earlier
Okay,
time, it wasn't. Right.
got it.
All right. So because we don't have any, dry run kind of thing for application controller as of now, So we need to understand how exactly we are going to create a replication controller. And that is very simple actually. You have to, just understand how pod is getting created. I think my battery is not connected. Let me just, so it's automatically getting disconnected. Just give me 1 minute, guys. All right. So now, how we are going to create replication controller. So it will be very much similar. So let me just hit that command. Let me store pod1.yaml. And from the same pod1.yml, I'm going to tell you how exactly we can create replication controller. So let me just open gedit. You can just, take an example. So what I'm doing is I'm just taking this entire copy of pod. Okay, I think from somewhere they must have option to highlight it. Okay, so this is my exactly pod. Now to create replication controller, everything will be same till here. So what I'm doing is till here I'm gonna use the same thing. Okay, because we don't have any dry run. Rather than writing pod, here we are going to use a replication controller, and controller has C capital, right? Replication controller, and then labels, whatever you can give. Let's say label x is equals to hello one. Okay, it doesn't matter what label you are giving. And here the name of replication controller, let's say my RC, and then specification. Okay, because you know what, the job of replication controller is to create a new pod whenever the pod is down or deleted. So that means, if you remember that fact, whenever we create pod, we need to be sure that the label is there so that service can access. Okay, so, and this was managed by us as a Kubernetes administrator. Now, as a Kubernetes administrator, we are not directly creating pod, we are creating replica set. And replica set is creating pod, or I can say pods. It can create a single pod or multiple pod, right? When this is the case, what you need to do, you have to understand replication controller needs to be take care of pod labels. Okay, so whatever the attribute, image, port number, and pod label will be there. So replication controller will write everything as a template. Okay, now replication controller will use this template to recreate the pod again and again. So what you need to do is you need to write here under specification templates. Okay, I think it's E only template. Now under template, you have to give the metadata. That means what is the data of template, okay? And then the name of metadata, let's say, I can say my application pod, okay? And then the label. What will be the labels of my pod that will be given? So this name of pod it will be creating, and the labels will be like, let's say I'm giving x is equals to Ashutoshh pod 1. So see, you need to understand here template, under template metadata, and this is the name of pod. I'm commenting here name of pod, right? And here label of pod, label of pod. Now the same section, right, where we exactly creating pod, we need to take copy of it, and we need to place this in the symmetry of metadata here, paste, right? Sorry, not saving it. So what I'm doing is, you have to understand very similar thing, and that is we have this API version, then specification has a template, and template has metadata where this information is about pod, because you know what, the name of pod and label of pod is important, but the pod we are creating, it will contain what kind of container. I think containers, it will be in indentation like this, okay? But here still one thing is left, and that is, as I told you, pod is sorry, replication controller is designed to control number of pods, how many pod you want, okay? So here under specification we have replicas keyword, let's say 1. So when you put this number will be maintained always, right? So replicas is a keyword, template, and template has this exactly name of replication controller and all this. So this is your entire information about this. Let me copy it and create my first replication controller.yml. Okay, see. So now kind API version, create my replication controller, this, under this we have this, and this. I hope I'm not doing any syntax mistakes and keywords. So if I just save this and I'll do kubectl create -f my first RC, and yeah, it got created. I can check replication controller, replication controllers. So now the desired is 1, ready is 1, current is also 1. And if I'll check the pods, see, this pod got created. Okay. Now, one more thing, even if you check where exactly your pod is running, I mean in which node, so I can check here in this node pod is running, and which is that node exactly. So this is my worker node 77.2, worker node second from the top. This is my worker node IP, it is here. This is my pod IP, and it's running. Okay. So now, due to any reason, even if you delete the pod manually, let's say if I delete kubectl, delete pod like this, even if you delete, nothing has to be worried about this, because my replication controller take the responsibility to create the pod again. You can check the time 7 seconds ago, or the 64 seconds have been done. Okay. So here, due to any of the reason, if the pod got deleted or something, so Kubernetes replication controller will create that. You can also check replication controller by RC. Okay. So always remember, if you want to check what the detailed information about RC, so you can use kubectl describe replication controller. Okay. And here you can check, we have this label, this pod information, and many more things. So we just don't have to worry about it. So this is your replication controller. Now in the replication controller, you can always increase the number of pod if you want. So the best way or the better way is to, just edit the replication controller file that is running live. And once you are editing, just go down under specification and try to change the replica 1 to 3 and save it on the real time. If you do it, it will be affected automatically without restarting or recreating any service. You can see here 4 seconds back, these replica got created. Now replication controller will maintain 3 pods for you anytime. Okay, so this is the most amazing way to change in the running replication controller by doing edit, and it will maintain everything for you. So once the Kubernetes major release was happening in 2016, replication controller came that time, and a lot of people are using replication controller to maintain the high availability of the application. Okay, I think we also have scale command, right? If you want to scale without editing the file, let's say 10, the name of replication controller. So this scale command is also being used by a couple of system administrator and Kubernetes administrator to scale number of pods automatically. You can scale up and scale down, and it's pretty fast. The good point about a replication controller is ultra fast. See, only 2 is there, rest are in terminating state. All right, I hope I'm not going fast. You guys can interrupt me in the middle if it is so, right? So as of now, everything is okay, guys. Nived or Anwar, Rajat. Pace is fine. Okay, great. Wonderful. So you can take a look around the same, because whatever the purpose of replication controller in the beginning of the time when the Kubernetes was designing, that was perfectly fine. And replication controller is doing very well, right? Now to access your application, we know that we have to create the service. Okay. So during service creation, we only have to focus on one thing. We need to take care of the same label that has by your pod. If the service is not having the same label, you have to maintain that. So let's say if I create my service manually, like create service, and I'm going to create this time node balance node or node port type, then hyphen okay, and hyphen service name is Ashutoshh svc1 svc1, then hyphen TCP 80 port, and it got created. So node port service got created right here, and it is exposing the 32131 port number. Okay, but we have to check that the service has the same selector as this. If I want to check here, I can use kubectl get svc Ashutoshh service hyphen export, and once I do that, and hyphen oyaml. So under the selector, the label is not same as pod label, right? See, the pod label is x is equals to ashu pod 1, but the selector has something else by default. Okay. Now, if this is the case, and even if I try to access my application by using master or minion IP 32131, it will not be accessible for sure. So if I'm going here and it's 32131, the application is not accessible. And the reason behind that is you have to match the same label under the selector section of service. So what I have to do is I have to take that one, and I can update a label by editing service in the real time. Okay, so I'm going down and waiting for the selector. Then I'm just checking here. I need to use colon like this. So here, if I'm saving this without any point, and I can just check it by YOML, I got the same label. So now the selector has the same label as pod is having. So let's just refresh it now. Welcome to Nginx, right? So I hope you are understanding, and we had a really long session about why label is important and why label got chosen here. But you know what? This is not the best practice to create service first, then check the label and edit and match it. Okay, the right practice is, let me delete that service. The right practice is, if you have replication controller running, okay, the right practice is to use kubectl expose command. Okay, now what we can expose deployment, pod, and replication controller, and so many things. So I'm just exposing replication controller, this one, and here I'm gonna write -- type like node port, right, and 80, the same port that your web application has. We had a discussion about the same, and hitting enter. So if I do kubectl get svc now, whatever port number I'm getting, 30304, 30304, right, it will give me that application access. And the reason is because that's what expose is all about. So what expose is doing, expose is connecting to that API resource, that means the replication controller myRC, and it is checking the template section of labels, and it will take that label and put under the selector of your service. So if you do expose pod or replication controller or anything that we have, it will take that label from the existing node, existing entity or API resource, and it will use the same to get it. So even if you see get svc -f export -oyML and my RC, right? So see, it has same. So the best practice is always to use expose command rather than creating a service. So you're just free from matching the label and everything. So it's pretty awesome, right? So this is the story of your replication controller. All right. So if all of you are very much okay with replication controller, say yes in the chat window, then we can go ahead. All right. Good for Rajat, Anuva, and I believe for Nived also. So now,
Yeah, okay.
you know what? These days we are not using replication controller at all, right? And that means we are not using replication controller at all because of some reason. So as a Kubernetes engineer, you have to give me the reason. If you know, you can give me, you have to find a reason before tomorrow's session. We are not using replication controller anymore. You have to give me the reason why. So it's a kind of homework from my side why we are not using replication controller. Instead of replication controller, Kubernetes has designed another API resource. We call it Replica Set. Okay, so Replica Set is just doing the same, very much same, whatever replication controller can do. Okay, so to assignment, it's a conceptual assignment. If you know, you can tell me right now. You have to give me the reason why replication controller got closed and why we have replica set. Okay, so you need to tell me the difference. Okay, so because of that reason, replication controller is no more in trend or no more in use. We are using as a replica set now. In terms of writing YML file, replica set is also not having any of the kind of dry run. So we have to write a replica set by own, right? So what we can use, first of all, I'm taking the same copy of replication controller, even y here. So let's say my first, so replica or rs replica set dot yml. Fine. So I'm just making a copy of it. I can tell you the difference because it's really easy to switch between replica set and replication controller. So the difference you have to tell me tomorrow, right? The first is because in replica set we have version 1 of API, but in replication controller we have API version got changed, that is apps/version 1. And here we are writing replica set with S capital. Okay, and I'm giving the label, let's say hello2 and my rs. Okay, the keyword like replica will have still same keyword, right? And template is also same. Everything like I'm giving my pod name is like my app rs pod. Label I'm just changing it to 2, right? So as of now, everything is same till here, till here. I'm giving, let's say, container name like pod 2 and same. But in replica set, one more field got introduced, that is selector. Okay, now the selector has a keyword called, I think, match label, right? I need to cross check it. Qvectl explain replica set dot spec. Okay, and then we have a selector dot selector, and that has a match labels. Yes, label has L capital. So I'm just using here, it has selector, then it has match labels. Under the match labels, what you have to do is you have to give the same label, right? You have to give the same label like you are giving here. Okay, so once you tell me the difference, what will be happening is you will understand why replica set has this. So you have to either Google it or do some research and tell me, but only extra thing got added in replica set is this line and this API version. So if I just deploy Qvectl create -f replica set, enter, I can tell you kubectl get replica set C, and the short form is RS. Everything is working fine without any failure. Even if you also delete the pods of replica set, it will recreate it automatically without any failure. Okay. And the same way, if you want to, create kind of service, okay, if you want to create service, so the same way, kubectl expose replica set and the name of replica set hyphen type and no port hyphen port, let's say 80. This is service got exposed like this, and you can access it without any failure. So always this is the priority, that use your service without any failure. All right. So, and this is the story of your replica set. These are very small difference topic. The difference you have to understand. Okay. I mean, you have to tell me by tomorrow. If you're not able to do that, let's see, then I'll give you that hint. All right. So still I'm expecting that you guys will be maintaining on mending same. So what is the history of Kubernetes as of now? So as a Kubernetes engineer, we tried to deploy Docker image, and the journey started from pod. Then it came to replication controller, and finally to replica set. Okay. And every journey or upgradation is just to solve one problem, that was downtime of application. Okay. So one of the big motive behind downtimes, so the word best technology or engineering these days is SRE, right? So SRE is the best technique to maintain the downtime. And Kubernetes is also connected somewhere to SRE engineering, right? Because Google created Kubernetes and Google created SRE. So if someone gonna ask you what exactly the best technique to maintain your downtime of application, so the right answer is SRE. Okay. And it has a couple of similarities and engineering approaches, very much similar to Kubernetes. Anyway, but you know what? We are here in Replica Set and we are still not satisfied. So Replica Set got designed by Kubernetes engineers, controller got designed, pod got designed, so many things are there, and we are still not using Replica Set, right? Now, if there is no Replica Set, what else? First of all, we have to understand the problem in Replica Set. So let's say you have a Docker image called Nginx, okay? Any Docker image. And you created replica set and you given replica as a 3 pod. So what just happened? Pod number 1, pod number 2, pod number 3 is running without any failure. So all the pods are running tick, tick, tick. Okay. And there is no problem in replica set. Even any of the node will go down, replica set will maintain that count. Everything is working fine. After a journey of 3 months, your company has decided to upgrade your application from version 1, let's say it was your Nginx version 1 to Nginx version 2. So what you have to do, in your replica set definition, you need to change the image from Nginx version 1 to Nginx version 2 that has the right upgradation changes for your application. So once you change the replica set image from version 1 to version 2, what is going to happen? Replica set will destroy these pods, and on behalf of them, from the new image, it will create 3 new pods immediately. and that is good thing. Okay, that is very good thing, because we have just upgraded that image from version 1 to version 2, and now we need new pods, so it got destroyed and created. So any customer now, they will be getting the most upgraded web application. Okay, and that is very much uh, in a very much better way performed by Replica Set. But still the problem is, once you upgrade this image version, Replica Set is terminating all these pods accidentally in one shot, right? So once Replica Set receives the versioning of image, it will terminate all the pods without worrying about, even if some customer is accessing your application and some important thing is going on. So they will terminate the existing connection and they will terminate the pod. And this is what a bit of downtime is created, right? So we are in the world where we are not trying to, bear any of the downtime as of now. So definitely we are not going to accept this replica set if this replica set is dominating those application in one shot. Okay, so this is the reason why people are not using replica set now. Okay, if you don't have problem with the downtime, trust me, replica set is pretty amazing, pretty fast. You can use that, there is no problem at all. So all of you, I hope if you are understanding the same, just say yes in the chat window. So Anua has given some answer, rolling update in case of OpenShift. So the same for Kubernetes, difference, not exactly, Anua. Yeah, rolling update is the same as Kubernetes OpenShift, but the difference in Replica Set and Replication Controller is not rolling updates. Okay. Yes, for now, as of now. Okay, so you are understanding it. And if Nived and Rajat are here, okay, great. So if this is very much something. All right, so what is the solution to this problem? So the solution to this problem is deployments. So now in Kubernetes, we are going to create deployments. So deployments are very much similar to Replica Set, but it has some advanced facility that Anua has already introduced. So what deployment can do, let's say if you have version 1 of the application and 3 pods are running, 1, 2, 3, okay, and you upgraded version 2. So what deployments will do, or how deployments is going to upgrade application? First of all, it will take the pod number 1. It will serve the existing connection, but it will not accept any new connection. So until unless any existing connection is not being served, this pod will not be deleted. So once the connection will serve, no new request is coming because it's blocked. So deployment will delete that, and deployment will create a new pod from the new image. Still the count is maintained, 1, 2, and 3. And then it will select another pod, will do the same. It will serve the existing connections and block the further request for this pod only. And once it is served, it will delete it. And on behalf of this deletion, it will create the new pod. And it will do the same for this pod as well. So that means it is creating, deleting, deleting, creating, and deleting, creating likewise, one by one. That is something we are calling it rolling updates. Okay, so rolling updates feature got introduced in deployment. So this is how your application will almost not be going down for even a second, right? Because anytime the pod will be present without accidentally terminating. One more thing about rolling updates is deployment has one more feature that is very amazing, and that is also rollbacks. So let's say if you uploaded your application from version 1 to version 3, the same thing is going to happen. You can go back to any of the version either this way or directly to this way. So rollback feature is also there in deployment, although that was also there in Replica Set, but rolling update is the feature that is there in the here, and it will create and terminate one by one. So these days is people are using deployments rather than Replica Set and Replication Controller. So I think the rolling updates feature is the game changer here. But you know what? What is the reality? What is the reality? The reality is deployment definitely does the support rolling updates, right? And rollbacks and rollbacks. Still, deployment cannot maintain or manage pod count. So let's say in the beginning, if you have created 3 pod on behalf of deployment, then the maintenance of pod cannot be maintained by deployment. Even now, we cannot. So what the reality is, deployment is first creating replica set in the backend, and that replica set will maintain the pod count. But whenever you need upgradation of application, then deployment will come in picture, rolling updates and rollbacks. So always the reality is, even these days as well, if you do create deployments, first thing, deployment will create replica set. Replica set create replicas factor that will maintain the number of pods. So even if you're creating replica set, it is also maintaining pod. If you create deployment, it will create replica set, then replica set will create pod. And it support rolling updates and rollback. All right. So this is the reality. So if I just draw a life cycle diagram of Kubernetes, so we started with the pod, we came to replication controller, we came to replica set, we came to deployment, and deployment is actually connecting to replica set to perform the job. So still the replica set is in picture, even if we are using deployment, right? So I hope it will be very, very much fine as of now, right? We'll be discussing about the same Nived blue-green deployments. Okay, so not a problem. I'll tell you the exact reason. Okay, but you are understanding the reality of deployment, that it is dependent on replica set these days even. So if it is all cool for everyone, so we can create deployments for now. All right. So for Nived, it's okay. If Rajat and Anua, you guys are here, you can just which point, Anua? I didn't get your question. You didn't get my point, which I started, like what? You can unmute it. Okay, you understand the deployment, but
Yeah, I'm not able to get the difference. I mean, you started that why replica set is not getting used. and then you came to deployment, and then I'm not able to get it. And you say that deployment is using Replica Set. So I'm not able to understand what message you wanted to give here.
Okay, you already answered that between RS and RC and RS. So you said that probably rolling updates and rollback is the difference between our replica set and replication controller, but that was not. So I introduced deployment by showing the thing here. See, so if we upgrade application in replica set, it will destroy the pods immediately without checking the existing connected customers or users. And it will create new pods from here. Okay, that means replica set is not supporting rolling updates. It is immediate upgradation. So if you cannot bear downtime, then you have to create deployments, and deployment supporting rolling updates and rollbacks. But deployment is supporting rolling updates and rollbacks. Still, the number of pod count is maintained by replica set. If some pod got deleted or got damaged, so replica set will connect to deployment and will manage by replica set. So that means only the number of pod counts is maintained by replica set, not the feature like rolling updates, rollbacks, and versioning, and many more things like that. Right? Right here. So deployment is using replica set just to maintain the count of the pod. All okay? Still confused? Great. Let me show you that example. So what I'm doing is, let me delete everything as of now. And let's create deployment first. Okay. So deployment you can create by command line itself. Kubectl create deployment. Let's say Ashutoshh dep1. The image I'm gonna use is Docker ashu/ckad version 2. I don't know. I need to search that image in Docker Hub. Waiting for a second. All right, now so I have this. This is CKD, and the tags we have is yes version 2. So what I'm doing is version 2, the image I'm using, and here I'm using -- dry run -oyaml. Okay, so just showing you the output file. Let me just save in a directory called Ashutoshh deployment1.yml. And if I open this file, you can check the API version of replica set and deployment is same. Even replica's keyword is same, selector match label is same. Here we found something strategy, templating, and everything is same. Okay, almost everything is same. So if I just create deployment like this, see, so the deployment got created, and we can check by kubectl get deployments, or you can use short form like get deploy, right? So the pod is in ready condition, and I can check the pod. Yes, it is running. But the reality, as I told you, whenever you create deployment, actually once you create deployment, first replica set got created. See, replica set got created, and this replica set is maintaining that count, and that's why we are able to, handle these deployments as a pod count, right? Now what you can do, you can expose your deployment as of now for deployment name Ashutoshh dep hyphen type is node port hyphen port 80, right? And if I check vector get service, right here we have 32164 port number. It's 32164 port number 32164 32164. Yes, so we have this application that is already there, right? So now if I want to scale it up, same way, kubectl scale deployment name hyphen replica is 5. So we have this thing as a, now we have 5. All those pods are in creating state. Now one by one they will be in running state because they are creating pod one by one, not in one shot. Okay, get pods, and now the pod is running. We have so many different varieties. Every pod has its own IP and its own node where they are scheduled. Okay, so but before talking more about deployment, I really want to tell you that if you have multi-pod application like the way we are having multi-pod application, in general, the service you have to use is load balancer type. It's a recommendation from Kubernetes itself. Because see, we have pod 1, 2, 3, 4, 5, and these pods are scheduled across 3 worker and 1 master. Okay, and across 3 workers, somewhere 5 pods. Okay, now the service node port is also good, but when you have multi-pod for the same application, because the reason was because you want to balance the load. So always prefer load balancer type service, so that when you create a load balancer type service, people can hit here and then this service will distribute the traffic across the controllers. Okay, likewise. So definitely that will be working. So always try to create a load balancer type service. So if I just check the list, what I'll do, kubectl delete service, and this time I'm going to expose deployment, and I'm going to type load balancer.
Ashutosh, I'm not able to see where are you typing this.
Sorry,
I cannot see where you are typing it.
is it?
Yeah, now I can see it.
Just let me. Okay, fine. So I'm just creating load balancer type service. It is the most recommended way. Fine. And because load balancer, it will also create node port so that you can access it likewise. Okay. But you know what? The story is something different. always in production environment, let's say the reality check. Okay, reality check is if you create a load balancer type service in Kubernetes cluster, that doesn't mean that all the pods are distributing traffic by this load balancer. Actually, node port is also doing the same thing. If you hit the traffic, node port can also balance the traffic across worker node. So when node port can balance the traffic, then why we are creating load balancer type of service? So I think you have to just focus on this point for a little bit. So load balancer is doing the same thing what node port can also do. That means node port can also balance the traffic across the pods. Then why? Okay, so first of all, make a note of it. The note and the most important point is in production environment for any bigger application, it is never recommended that your traffic is directly hitting on the master and worker node by the customer. It is never recommended, because if you're directly hitting the traffic on the master and worker node to access your application, the bandwidth consumption of master and worker will be low, specifically for master. Okay, so to remove the dependency from master and worker node to access application, what we have to do, we have to create a separate application load balancer, the real application load balancer outside this cluster. So people can not hit directly there, they will hit traffic here. Okay, now this application load balancer also have cache. So that means if the content is very much same for the same user, this load balancer can serve from here itself. That means if I'm searching for the same and same content every time, this load balancer can have cache and it can serve itself until the application is not getting updated. So your traffic will not be go there after once it got redirected. Now, if there is a new user, this application load balancer will balance the traffic across the worker node. So user don't have to hit directly. User will hit application load balancer and it will redirect the traffic to the worker nodes. Then worker node will connect to service and service will connect to pod. Okay. So exactly this is the actual scenario in production environment. We are never supposed to use any of the node of either OpenShift or Kubernetes, right? But the problem is if you as an OpenShift engineer or Kubernetes engineer, if you don't know how to create application load balancer, then there is a problem. You need to be dependent on any other team who will create network or application load balancer for you. Then you will be configuring the same. So every time you have multi-pod application, to create a separate application load balancer outside the cluster, then this application load balancer will be connecting to these, and they can be in private network and the one interface will be in public. So you don't need to expose your master and these publicly actually. So now the thing is, if Kubernetes is managed by cloud provider like Amazon, like Azure, like Google, and these days like Oracle also, and now VMware. So we have so many companies who are having Kubernetes as a service in the cloud environment. Like Amazon has EKS, Azure has Azure Kubernetes services, Google has GKE, and many more, right? And here in this cloud-based Kubernetes service, if you create a load balancer type service, what Kubernetes will do, it will connect to Amazon Cloud and it will create a real application load balancer here in the cloud itself. Okay, so the purpose of load balancer service is to deploy a real load balancer in the cloud environment, whatever cloud you are using. If you create a load balancer service, then you can share this URL of application load balancer. People can hit here, and this load balancer will be redirecting traffic to the worker nodes. Okay, so I hope it will be very much clear. The purpose of load balancer service is not to balance the traffic. It's just to create a new independent load balancer in automatic cloud environment. If you are using custom cloud, you have to create that application load balancer to use it. So if you guys are understanding.
Yeah, for an example, if you're running an web service, then you probably use Nginx as a load balancer there for that, right? Something like that, reverse proxy kind of a thing.
That we can manually deploy. But what I'm saying is, let's say in our case, my deployment is running and I've created load balancer type service here. And this Kubernetes is not managed by me or you. It is managed by any of the cloud provider like this list. So this is managed by any of the cloud provider. Then once you create load balancer service, it will create a real load balancer in the cloud environment. That means, let's say this Kubernetes cluster, although it's managed by me as of now, but every cloud has Kubernetes as a service. Like we have EKS, Elastic Kubernetes Service in Amazon. If we launch cluster by using EKS, so that means EKS means now Amazon Cloud will manage that Kubernetes for us, fully managed Kubernetes service. So in this case, if you create a load balancer service, what Amazon will do, it will actually deploy a real application load balancer in its cloud environment. Let's say it will deploy the real load balancer here. Right? The real one here, real one. That is separated from Kubernetes. And that is not a reverse proxy, that is a real load balancer.
That's a hardware thing.
Yes.
Yeah, got it. So performance will be a lot better. That's what they're
much better.
Yeah.
Because independently you have hardware load balancer, you have better bandwidth now, and a couple of things are improved. All right. So I think Rajat and Anua, you guys are also here. And if you understood it well, then say yes in the chat window. Okay, fine. And still you have any problem, you can please buzz me here. I can answer your questions. All right. Even if you check here in Kubernetes, it is saying external IP is pending because Kubernetes is looking for API callback if someone is deploying application load balancer for me or not. So if this was a cloud managed, then here the application load balancer IP will be reflected. Okay. Still, if it is not getting created, you can access it by the standard way because it has also created node port. Let's say if I want to create an application load balancer. So if I want to, I can create it. So how I can create it? I can create it like this. I can create load balancer and I can give a name. Let's say Ashutoshh LB. And then load balancer protocol is 80. And what is the instance protocol? That is 30594 because we have to give that port number. and that will be automatically managed by Amazon. Now I'm using security rules. I'm not using HTTPS as of now, and interval is 10 second, timeout is 2 second. Just to make it quick, unhealthy 2, healthy threshold 5, and I'm adding, all worker nodes, worker 3. Connection drain time is 150 seconds is better. Okay, I'm not explaining this load balancer thing, but I'm just creating it so that you can access your application either by IP port like this or directly by load balancer. See, as of now, this is your DNS A record name of load balancer. It will take some time like a minute or so, but it will deploy here. So as you can see here, a 0 out of 3 instances are in service. So definitely Amazon is, creating this load balancer, hardware load balancer for you. Then it will make it ready. Then it will connect to the instance and it will follow the health check rule. So 5 consecutive times in every 10 seconds, it will connect to access this index.html page of instances or the pods, I can say. If the pod is responding back, so 5 times 10 seconds the interval means 50 seconds in short, and in the delay of seconds, so we have to wait for 3 out of 3, or in the instance I can say out of service as of now. So it will take 2 minutes or so, then it will be balancing that traffic. So as of now, if I'll just open that page, definitely it will not be reflecting what is happening. See, it is not reachable because this load balancer will need some time to come up 3 out of 3. Wait for 1 minute or so. So just a minute. Yes, 3 out of 3. And instance is in service. If I'll refresh it now, yes, we get it. So I'm sharing this load balancer DNS A record. You can just cross check it by accessing. It is also accessible from your own end. Okay, let me know if it is not accessible. Okay, for now it's working. I hope same for Rajat and Anu also.
So one quick question.
Yeah.
Now I have an application
Okay.
which is already using I've already purchased a domain, right? So suppose the domain is phealthcare.com.
Okay.
And then I go ahead and deploy this using this load balancer. Then the DNS name that is giving me something else, right? So how
Yes.
do I make sure that my DNS record is updated, or it's probably forwarding the traffic? It's a CNAME
So
record I have to create on a
in
DNS
short,
level.
you want your own name, the one that you purchased.
Yeah.
Okay. So for that purpose, let me tell you one more thing. So as of now, let's say this is your K-test cluster, K8S cluster, and that is your master, and these are your workers. The pod is running here, okay, and that pod has its IPN port. Then you created a service. Service also has IP port. I'm just re-explaining it. Now the service created a node port, even if you create load balancer type, then, and we have 3 IPs of workers, even one manager also, but we are excluding that, and this node port, right? Node port. On top of it, we have application load balancer that is either listening on HTTP or HTTPS connection from customer. So customer hitting here. Now this is connecting to these ones. But whenever you create a load balancer, it will give a random DNS name,
Mhm.
random DNS name, and the one that we are using. See, this is very random. For example, if I have purchased like ashutosh.com, so I have a domain called ashutosh.in. What I want is I definitely want to access my application by, let's say, for example, redhat.ashutosh.in, by this name, not by this big name. So if you have purchased domain here, so now you have to understand the DNS controller will be to this provider. Now, anyhow, you want that people can come to this website. So you can create this name in your DNS server by the provider.
Yes.
Say you have purchased from
Even
GoDaddy or somewhere. So people will come here. Now here,
correct.
you already have a name of application advanced. So what you have to do, you have to create a CNAME record.
Screen and record. Yeah, that's right.
Okay. Even I think I have my GoDaddy account here only. So let me show you. GoDaddy. Definitely because no one want to access by this big name.
Correct.
So if I sign in here, I hope my username password is connected with my current email address. Yes, it is. So now let me just check on DNS. So it is taking some time to load, but let's wait. Meanwhile, I just I'm copying this big name, this name, and what I'll do, I'll add a record here, selecting CNAME record, and I'm giving Red Hat, pointing to this, details 1R, and save. So if my domain name is ashutosh.in, that is here. So my CNAME is redhat.ashutosh.in. It is going to the balancer. And let me check that DNS got updated or not. So host redhat.ashutosh.in. So sometimes it is taking time to update. No, Red Hat, not Red Hat. Red Hat. Yes, wonderful. So now I can check it. So if I type redhat.ashutosh.in, yes, I'm getting it. So I'm also sharing this in the chat window because DNS propagation can take time. Check it. Must be working. redhat.ashutosh.in. Okay, wonderful. So here you can use your CNAME facilities, and you know what, you can also configure caching in the DNS for a better performance. So we have so many big caching DNS server, like you can always go for Cloudflare. It's the much better option, right? Because it has caching and high performance DNS. Even it has CDN also. So if you have CDN based DNS, always prefer that kind of DNS. So CDN based DNS is the best for performance. Even
Yeah,
your yes, Nived.
even I use Cloudflare. It takes around 24 hours for the caching to work, right? They keep a copy of your website as a cache. So even if your server is down, your website never goes down. It's really good. Cloud
Yes.
service is very nice. Yeah.
So this is very good provider, and the most important part is you can use it for free. Couple of services.
Three domains you can use it for free.
Yes. So anyway, so this is something that is here. Now let's say this time my deployment is running and I want to upgrade my application as of now. So definitely as a developer, what I have to do is I have to create a new Docker image. So I'm going into my local machine and let's say I'm just going here app 2 or app 3, and if I'm going there, let me create a Docker file. So Docker file, and the from what I'm using is this one. Okay, so I'm using this image and I want to upgrade something, but first of all I have to pull that image just to be sure about few things, because I need to understand how and what is the architecture of this image, because I don't remember that time what environment variable I just used it. So I'm just checking that one, right? I'm not using it. ITD name OK1 and this name, and I'm going there by exec OK1 bash checking environment variable. So it has I think color green. So in the start web.sh, if the color is green, I believe, then we are having this green.html. Okay, so I have to make sure that I'm not using this one. So what I'll do is I need to actually use another application there. Fine. So what I'm doing is, let's say, let me take some sample HTML code, sample HTML code from Mozilla Firefox, and I'm creating new get clone this. So I hope you're not having any problem with using web app. Okay, I'm using Docker file this time, not using this one. Let me use nginx image, nginx, and maintainer is Ashutoshh. Then walk dir is usr share nginx html. Then add dot to dot. Okay, so I'm using this entire, even let's not add dot to dot. I'm adding this web app folder to the target location. Okay, so nginx already have their parent process maintained. I also need to use a docker ignore for better ignore, and here I can just ignore .get readme.md and license file and even docker file to get copied. Fine, let's build this image. Docker build -t docker ashu / red hat CKA version 1 and dot. right? So I'm building this image. So you have already learned Docker, so I don't think so there is any problem. So it is now building that image. Image got built. Let me just test it, this one, before actually running it to the, uploading it to GitHub. So I'm using Docker Ashutoshh / Red Hat this 1111, using it locally actually. So local host 1111. Yes. So now if it is running, I am logged to Docker Hub. Right? And after logging, I'm pushing this image to Docker Hub so that Kubernetes worker and master can take the image. Definitely if it is not on the Docker Hub, Kubernetes cannot take that. So this is my local machine. This is my Amazon cloud machine. I can see. And now the image got uploaded. So I need to update this image because I'm upgrading my application. So how do I do that? In general, if I see Docker, sorry, wind up, kubectl get deployment, right? So my deployment is having some image. What image it is having, I can just check by describe deployment command. So it is having, this container name CKD and the image is this. So how I upgrade the image? So I can use kubectl set image deployment, and then the name of deployment, and then the name of container. CKAD is equals to the name of new image that I have just built. So name of container and the name of new image. Once I hit enter, this image got updated, and I can show you by describe. This image got updated, right? And once this image got updated, rolling updates is automatically happening, and I can show you by get pods. So all the 5 pods are in terminating state because we have not any active connection. Still it will maintain that rolling updates. And once everything is ready, it is taking some time, right, to terminate it one by one. See, now all the pods will be terminated. And if I refresh my website again, let's say Red Hat, see, I get it. So now my application got upgraded from the previous to the new version, and that upgradation happens by setting image. You know what? The rolling updates is actually happening automatically. You don't have to do anything, right? And if I want to roll it back, then although I'll be talking about this in a little bit, what I say, advanced way, but I'm just doing rollout, undo deployment name. If I do rollout, that means I'm just doing is roll back. Again, it will take the pods, it will terminate it one by one. And once everything will be terminated, then it will change that pages to the previous version. Okay. So about versioning or version history, it will take some time, right, to keep terminating that things. And once everything is done, if I refresh it again, I got this page. Okay, so rolling update is a very much better thing, by the way. So I'll talk more about it, not today, but tomorrow. So I want you to, repeat the things, and you can actually revise, try to understand, try to figure out differences. And I'm just telling you, giving you one more hint. Pod, replication controller, replica set, deployment. You know what? In maximum of the real world applications, those are session based, database based. So we are not using any of the things in the real world, right? So if the application has session, application has database, even people are not using deployment for this multi-tier application. So we have another thing, we are calling it stateful sets. So if you have database oriented multi-tier application, in short, in the word of microservices, right? So we are using stateful sets. Okay, I'm just giving you some idea. We're not going to use that anyway because without microservices. But yes, as of now, for you, deployment is very good one, because you guys are, instructor, trainer, and somewhere cloud engineer. So you need to understand that is the term stateful sets as well. All right. So done for today. If you have any question, please do ask. Rest do practice.
One last question.
Yeah.
So in Docker, now this thing that you showed about different versions, deploying different versions, in Docker we used to use Git, right? So we used to do a Git checkout with a particular branch and then redeploy that application using some cron jobs or something like that. Or you could do a CI/CD, whatever it is. Here, this is a set image command, right?
Yes. So what exactly is happening? In this case, you need to design a CI/CD pipeline, because developers is directly sending code or uploading code on GitHub. Then from that repository, a CI/CD pipeline will be triggered that will make a build of Docker image in general. And that Docker image will be pushed to Docker Hub or any other registry. Then from there, you need to deploy the application or update the application.
But the problem with CI/CD is that is depending on, that will create a new image and then the application is deployed, right?
So what's the problem there?
The image does not need to be created again.
Then how you maintain the version of your website?
So there are 2-3 things here. So one is there are multiple branches in Git and there are multiple places inside branches, right? So you have that version 2 happening on the same master branch, right? Or you could have a development branch and maybe a production branch, which also might have versions there, right? So for multiple versions, you can use CI/CD. But what about if I want to change the branch? That is where that Git checkout comes in. How do you do that in Kubernetes?
See, first of all, the approach you are talking about, it is not going to be used in production. See why? Because once the developer will commit the code on any of the version control system, you can never deploy that code directly into the any of the production Git. So you need to build that code first of all. Every time developer push the code on any of the source code management system, you need to push it. And if you're really interested in branch-based versioning, so the concept that you are using in OpenShift, that is webhooks, right? So by implementing webhooks, you can do that, but that is never recommended in real production environment, because the build must be taken care by some build automation tool like Maven, and like Docker. So Docker is also using for image build.
Yeah. This is not for production. This was just for a seminar that I'm planning.
Exactly.
This is just for a demonstration purpose. Yeah.
Webhooks you can use.
Webhooks I can use, right? Great. Okay, that answers it.
Yeah. So thank you so much, guys, and please do a revision. This video I'm sharing in the WhatsApp group, although all those video. Then see you tomorrow, same time. Okay.
Tomorrow, can you keep it a bit postponed because I have lecture till 5 o'clock tomorrow. It's going to be there for the entire 4 weeks.
So you want
From
me to do it
tomorrow.
at 5 or 5:30?
Oh wait, tomorrow. Just a second. Oh,
Sunday.
tomorrow is fine. I was talking about Monday. Yeah. Sorry.
No, tomorrow
So
Sunday.
tomorrow is fine. Then it's fine.
All right,
Okay.
guys, same time we'll be connecting. Thank you so much, Anwar, Rajat, and Nived. See you soon.
Thank you. Bye.
Bye-bye.